exothermic or endothermic? Which one would this be? Exothermic or endothermic? A. Exothermic. Why is it exothermic? Yeah, because you got this heat over here, right? And so products means it's being given off, doesn't it? Okay, and how about the next one, B? Endo, because reactants has heat in it, doesn't it? So the energy is coming into it to build the products. Okay. How about this one down here? C. Exo, you got it. And again, same reason, just in this case it says heat rather than saying an energy value, right? Okay, very good. So let's talk a bit about reaction rate. We had just talked about being endothermic or exothermic. This is what's called thermodynamics. Has anybody ever heard of that term before? Yeah? Okay. And that tells you whether something will happen or not. Okay? So for example, many things that require heat, if you turn the heat off and you don't give it extra heat, what's going to happen? Yeah, so boiling water to make pasta. We turn the stove off, is it going to be boiling water to make pasta anymore? No, no. And this is what's referred to as non-spontaneous, okay? Meaning it doesn't go forward on its own. Right. The other way of thinking about that is things that are not spontaneous or non-spontaneous, they are spontaneous in the other direction. So if you had your water hot to boil, it's going to cool down, isn't it? Okay. Now, this is a different thing. This is having to do with thermodynamics, whether it's going to happen or not. We also have what's called reaction rates. This is what's referred to as kinetics, okay? And it's how fast something happens. Probably the best way to think of this is that right now, the gasoline in the cars out there is actually oxidizing very slowly. If you were to come back in like 5 months, you may not be able to start those cars, right? Has anybody seen a car that's been sitting there with the gasoline in it? Doesn't start, does it? You gotta drain the gasoline out, preferably before you try to start it, and then clear it out with new gasoline, okay? And the reason for that is the gasoline is being slowly oxidized, right? And so gasoline oxidizes spontaneously. Why doesn't it all oxidize at once and blow up the car? Kinetics, how fast that's happening, okay? The other way of looking at it would be like the Grand Canyon. The Grand Canyon was inevitable. It is spontaneously occurring. However, it took millions of years to do it. And so in a single human life, no reaction's occurring, right? Because you wouldn't actually be able to tell how much it carved out the Grand Canyon in a single year or a single life. Just too long. Okay, so again, speed at which the reactant is used up. This is one way of measuring speed, right? How fast we use something up. The other way of measuring it is how fast we're approaching something, right? Or how fast we're making product. It's going to increase when the temperature rises because the reacting molecules are going to move faster, and more of those collisions are going to happen, and more of those collisions are going to be meaningful collisions. They'll have the energy to overcome any barriers. They're going to increase with an increase in concentration of reactants. You kind of knew most of this already, right? Has anybody ever made like those bottle rockets where you take the seltzer tablets and put them with an acid, or the baking soda and put them with an acid? No? Yeah? Okay. Has anybody ever seen gunpowder? Okay, why is gunpowder a powder? Or fireworks, why they're filled with powder rather than a solid block? Yeah, it reacts faster, so you get more explosion, okay? If you made it a solid block, it wouldn't be able to react as fast. Same reason as like the gasoline is injected first into your cylinder. So it injects the gasoline, it mixes it with oxygen, gets a good concentration in there, and then reacts, right? Because you get more explosive force, okay? On the other hand, temperature, everybody's probably experienced this in the fact that you've baked stuff, right? Okay? And so if you want it to bake faster, what do you do?
Pour gasoline on it.
That would work. You probably wouldn't want to eat it, but yes, you make it hotter, right? increase the temperature. All right, so one of the things you probably have not done is catalyst before. If you've taken biologists, you may have heard of a catalyst, which is an enzyme. Anybody heard of enzymes before? Cool. That is a catalyst, okay? So catalysts are going to increase the rate of the reaction. It's going to lower the energy of activation, and so it's going to lower this barrier right here. This is the energy of activation. It's the barrier you have to overcome to get to products, okay? You can think of it very analogous to walk to a school, okay? Anybody walk to school at all? No? Okay. Anybody walked between 2 points and there's things in between? Okay, fantastic. Any 2 points, put those in your head, okay? I don't care where you're going or where you started. All right, so if we have a very small hill in between, is it going to be a long, difficult trip? Not too bad, right? If we put a very large hill in between, what's going to happen to that trip? It's going to take a lot longer, isn't it? Yeah. And what if we put Mount Everest in between? Are we probably going to make it through that trip? No, there's very high likelihood we would not make it through the trip, right? Okay. And so that's the same thing that happens with this. The height of this barrier determines whether you're going to make it to the other side or not under the conditions you're at, i.e. the temperature. That's why gasoline typically doesn't oxidize very well when it's just room temperature. And then if you cut this barrier down, you're going to go faster and faster in that reaction. And so what a catalyst does is it takes this barrier and it shrinks it. It makes that barrier smaller. Okay. Now I will point out that when you make this barrier smaller, you make the reaction in both directions faster. So if you start at point A, you're going to get to point B faster. If you start at point B, you're going to get to point A faster, aren't you? Okay. It does not actually make a reaction favor one direction. Okay? So catalysts actually just make both sides of the reaction faster. Either way. All right, so these are some of the factors that affect that increase in reaction rate, just summed up into a nice pretty table for you to be able to copy easily. So let's state the effect of each of the rate on the reaction, rate of reaction, increase, decrease, or has no effect. So increasing the temperature, is this going to increase, decrease, or have no effect on the rate of reaction? Increase rate of reaction, you got it. Removing some of the reactants, it's going to decrease, isn't it? Yeah. Adding a catalyst, increase, very good. Placing the reaction flask in ice, it's going to decrease, you got it. Increase the concentration of one of the reactants. It's going to increase it. So if it's bouncing around and colliding with each other more, you're going to get more likelihood for reaction, right? So increasing concentration will also increase the rate of reaction. All right, so we're going to indicate the effect of each factor on the rate of this reaction down here. This one's going to be a quiz. So you'll want to get this reaction in your head or on a piece of paper next to you so you can see it. And then we're going to go through, and I think this one's actually broken if I remember correctly. We'll see. I tried to do something fancy and it may not have worked out like I wanted. All right, everybody got the reaction ready? Okay, so what would lowering the temperature do to that reaction? Okay, go ahead and get your answers in. You doing okay?
Yeah.
Go ahead and get that answer submitted. Is it going to increase, decrease, or no change to the rate of that reaction? Lowering the temperature. Okay, I'm going to go forward. If you don't have your answer in, that's too bad, I guess. Okay, most people said decrease, and that is correct. So lowering temperature typically is going to decrease the rate of reaction. Now, this is different than what we'd been doing before. Remember, we're in kinetics now. That's how fast things are, okay? We are not talking now about whether they're going to go forward under their own energy, okay? Which would be spontaneity. That would be the thermodynamics, okay? Just how fast it's going to happen. Yep, and that did not work. Okay. All right, so let's talk about the raising the temperature. What would that do to the reaction? Increase, make it faster. Adding O2. Increase, it's going to make it faster. Adding a catalyst. Increase, very good. Yeah, funny enough, if you copy and paste these things, they actually are the exact same item. Huh. All right, so let's go ahead and we're going to move on to Chapter 8 now. Does anybody have any questions about Chapter 7? Okay. What chapters are on the next exam, which will be next week? 5, 6, 7. Very good. So we are through the chapters on the next exam. What is available before the exam? Yes, the exams are always up and note. There's always a review available for the exam. I highly recommend doing the review before the exam. Okay. All right. Fantastic.